Okay, this is just another way to do number 5, and this is probably the way I probably should have done it, because I could have just used the square root of x at a equals 1, centered at 1, and this would probably be more like what we did before, so I'll put this in as a different 5, so you have two ways to do it. Either way will work. In other words, I just used f of x at the square root of x as the square root of x, and I'm just going to center this at 1. So that's pretty close to 1, and then we'll just put it in like this and see what happens. So I'm going to take my derivatives of x and square root of x, so that's x to the 1/2, etc., etc., etc. So those are your first, your function, your first 3 derivatives, and these are the derivatives if I put at f of 1. That's going to be 1, 1/2, negative 1/4, and 3/8. All right, and then when you put this through the Taylor's formula, there's Taylor's formula. Now the only difference is, when I did it a different way, I didn't have x minus 1, I just had x. I was doing that about x. But I was using the square root of 1 plus x. That's a little different. Okay, so this is my Taylor's expansion, and then I simplify this out, and this is what I get. And that's kind of where I noticed I had that type on the other method. And then this is your value. So everything's the same. It works out the same. It's funny. But some of you did it like this. When you do the error bound, you might have some problems and might not see where that came from. So here's the error bound. You can take a look at this. And we did the same thing, basically, except my interval now is going to be 0.8, because that's going to be my x and this is my a. So this is my x and this is my a. And again, I've got my derivative, and the derivative is almost the same, except instead of having x minus 1 for the derivative, I have just x. And then on this interval, again, the derivative is going to be decreasing, because as x goes up, this whole thing goes down. So it's decreasing, so I'm going to use 0.8. So this is a little bit different from the other method. It saves you a step. All right, so we have this. This is my m, the fourth derivative, but evaluated it at 0.8, the left endpoint. So that was my m. And then on 0.8 to 1, the maximum of my other term, this term here that I also have to find a bound for, or factor, the other factor, would be not at 1, because 1 minus 1 is 0, but at 0.8, because 0.8 minus 1 is negative 0.2, and the absolute value of that is 0.2. So we put 0.2 to the fourth. There you go. So here's the way the error bound would work in that situation. So there's your m. This is your m. And then the x minus 1 to the fourth, that would be 0.8 minus 1 to the fourth, the absolute value. Now we're always taking the absolute value of that, over 4 factorial. And then we've got this, again, this is the m. And then that's going to be negative 0.2. The absolute value of that is 0.2 to the fourth, over 4 factorial. And we get the same thing. So it's funny how you'll get the same thing either way. Okay, so I hope that helps.